So this is take 2 of the measures of spread video. I just recorded the whole thing and realised I'd had it on slow-mo setting and it was about an hour long and my hand was moving ridiculously slow. So let's try again. Here we are, we're going to look at measures of spread now. Measures of spread you met a little bit at GCSE, but probably didn't really know what their purpose was. So what we want to focus on now is not just what they are, but why we use them and why they're important. So a little example to demonstrate why they are so very important. Here we go. These 2 data sets here, I've called them X and Y, both have the same mean. The mean of X is 14 and the mean of Y is also 14. If you don't believe me, pause the video and calculate it yourselves to check. But look at the numbers. This set of numbers, measured from the mean, is not as spread out as this set of numbers. Because here we go from the mean, 1 down, 2 down, 1 up, 2 up. Here we go 4 down, 8 down, 4 up, 8 up. So these numbers are clearly a lot more spread out than these. Now, if you didn't know what these 2 data sets look like and you just said to me, well, the mean of the one is 14 and the mean of the other is 14, I might be tempted to think that the data sets were very similar, but they're clearly not. However, if you said to me the mean of this one is 14 and I can tell you how spread out it is, the mean of this one is 14, but I can tell you how spread out it is, all of a sudden I understand the data sets in a lot more detail and I understand the differences between them. So measures of spread are really important and they accompany measures of location and measures of central tendency like our mean and our median. So let's think about the measures of spread that we know about so far. We know about the range. The range is the largest value minus the smallest. So for this data set the range would be 16 minus 12 or 4, and for this one it would be 22 minus 6 or 16. So straight away we can see from just using the range that the spread of the second is bigger than the spread of the first. However, these data sets are pretty consistent in that they don't have any, they're pretty consistent, they don't have any extreme values on them. If you do have extreme values, they can distort the range, they can make it seem a lot bigger than actually most of the data is. And it's the same with anything in statistics. Any kind of extreme values can kind of tell lies, for want of a better phrase, and you need to make sure you're aware of them and you account for them. So the interquartile range is one way of doing that, because the interquartile range works out the value of the upper quartile minus the lower quartile. So it works out the spread of just the middle 50% of the data. And that's good because if your data does have any extreme values, this will ignore them, so it's not affected by them. But you don't just have to use the interquartile range. Perhaps you wanted to actually take into account more than the middle of the 50% of the data. Let's say you wanted to account for 80% of the data, but you still didn't want to be bothering about extreme values. You might take something, for instance, like the 10th to 90th interpercentile range. We call that one interquartile range, this one interpercentile range, and that would be worked out by working out the 90th percentile minus the 10th percentile, and that would take into account the middle 80% of the data. So let's have a look at example 6. In example 6 we have a table showing the masses in tonnes of 120 African bush elephants. So let's fill in our frequencies here. We've got 13, and I'm going to keep a cumulative frequency as we go along because it's going to come in useful in a moment when we have to interpolate. Then we've got 23 that weigh between 4.5 and 5 tonnes, so that takes us to 36 in total. Then we've got 31 of them in the next category, so that takes us to 67 in total. Then we've got 34 in the next category, so that takes us to 101 in total, and then 19 in the final category, which means overall we've got our 120 elephants all together. So let's work out the range. Now the thing is, we don't know how heavy any of these elephants are, we just know which of these classes they fall into. So we know we've got a rough idea, but we don't know exactly. So when we've got to find the range, we are going to have to assume that The heaviest is 6.5 tonnes, and the lightest is just 4 tonnes. So we're going to have to assume that the range is 2.5 tonnes. But of course it can only ever be an estimate because we don't know the actual values here. So our interquartile range we're asked to find next. Let's work out where the quartiles are. Let's do our lower quartile first, why not? So our lower quartile, we need to work out its position. That means we're finding out where the quarter of the way along the data is. So that's going to be 120 over 4, so that's our 30th position. Now, looking at the cumulative frequency we worked out here, our 30th position is going to be in this class from 4.5 to 5. So let's interpolate like we did in the previous video. Draw our line. The class starts at 4.5, it ends at 5. It starts with the frequency of 13 and ends with the frequency of 36, and we want to find the one in 30th position. So there's our Q1 approximately. And if you remember from the previous video, we said this gap over this one is the same as this gap over this one. And I'm not going to draw those colours anymore because I think we've gone through that enough, so hopefully this is starting to sink in now. It's an idea. So let's set up our formula. We've got Q1 minus 4.5 over 5 minus 4.5. That fraction is the same as the same fraction on the other side of the line. 30 minus 13 over 36 minus 13. Now I could simplify this and work with it. This is the minimum I write out because I have to show my working all the time. At A level, you only get marks if you show your working along the way. Even if your correct answer, if your final answer is correct, you have to show your working. But this is sufficient for working here. Any kind of simplification after that is not the important thing. What you've done is you've shown you know what you're doing. We're now going to solve that. So we can do it in one go. We've got 30 minus 13 over 36 minus 13. We're going to multiply it by the denominator here, which is 5 minus 4.5. And then we're going to add on that 4.5 there. So that gives us an estimate for the lower quartile of 4.87 tonnes. Let's do the same thing for the upper quartile. So Q3, find its position 3/4 of the way along the data. So that's going to be the 90th position. We're going to interpolate. 90th position is here between 67 and 101. So that class goes from 5.5 to 6 tonnes. So we know our upper quartile is somewhere between 5.5 and 6 tonnes. Frequency starts at 67 and ends at 101. And we're interested in the 90th, so somewhere up here. And that's Q3. Let's interpolate. Q3 minus 5.5 over 6 minus 5.5 is equal to 90 minus 67 over 101 minus 67. So therefore, let's use a nice little mathematical symbol. Q3 is times it by 6 minus 5.5, 0.5, add the 5.5. Before I show you the answer, could you please make sure that you are able to get these without just copying it down? Make sure you can reproduce this yourself. Also, if you're struggling with entering that into the calculator and you're not quite sure what I'm doing here, just practice simplifying all the parts of these fractions and rearranging this equation to make Q3 the subject. That's all we're doing. So we get 5.84 tonnes. That's an estimate, so let's put approximately equal to there. So that means our interquartile range, which is the upper minus the lower quartile, would be, what were they, 5.84 minus 4.87, and that's going to be 0.97 tonnes. So the middle 50% of the data is only spread out by just under a tonne. Now, part C asks us to find the 10th to the 90th interpercentile range, this one here. So you're asked to find P90 minus P10. I'm not going to talk you through it completely. What I'm going to do is give you a scaffold, and I want you to follow the scaffold and try and reproduce this yourself before you check the answer in the book. So the first thing you're going to do is you're going to work out the location of the 10th percentile. So your 10th percentile, you're going to think, right, I need to find 10% of the way along my data values. So something like this, n over 10. And that's going to be something position. And then I'm going to interpolate to get P10 equals. Now I'm going to do the same for the 90th percentile. I want to find out what's 90% of the way along my data. So I'm going to find out 9/10 of my total number of data values, find out what position the 90th percentile is in, and then going to interpolate to find out the estimate for it. And then I'm going to find my interpercentile range by going the 90th minus the 10th percentile is, and I'll get my answer there. Don't forget to put your units on it, and once you've got it, double check it against the book and make sure you're happy with it. When you are, have a go at exercise 2D.